Hello, everyone. Hey, please close the door. Yeah, thank you. Hello, everyone. Having a good time so far? Yes? Excellent conference. This is the session about C++ unit testing, the good, the bad, and the ugly. Coming to this session, I'm come from a background of several different object-oriented and dynamic languages. And it always amazes me that there are differences between C++ and those languages, and as far as unit testing tools and unit testing in general, and that's what I'm going to talk about today. And the good news is that C++ in some aspect is much better than the others, by the way. But before that, an introduction. My name is Dror Helper. I'm a consultant and software architect. Been working in the software industry for more than a decade. And somewhere along the line, about 10 years ago, I've stumbled or found a job with an agile company, agile startup, and learned all about agile and unit testing and TDD, and really liked it. And ever since, I've been speaking about those topics and mentoring developers and whatever, just spreading the word, how to write better code. Because we still have a lot to cover as developers, as software developers in the software industry in order to improve the way we're doing stuff. I'm also a Pluralsight author. I have several courses on Pluralsight, of which about C++ unit testing. One about unit testing fundamentals with Catch, unit testing framework I'll talk about today, and the other one about mocking with Google Mach. Feel free to check them out. I have a blog at helpercode.com where I write about anything I find interesting, usually software related. And I have a Twitter handle at @dhelper, where you can reach me. And I'll get notified immediately on my watch. So if you want to ask questions or comments, just feel free. And we are going to talk about C++ unit testing. But before that, let's talk about C++, because C++ is an amazing language. It enables us to do so many cool things. First of all, it is a multi-paradigm kind of language. We can write code, procedural, functional, object-oriented, meta-programming, you name it. It's also a very performant and highly tweakable kind of language. We can affect how much memory we use, how fast or slow our program will run. And we have so much control we don't have in any other language, at least ones I saw. And it is truly a multi-platform language, right? Unlike other languages who claim to be multi-platform, starting with the J, C++ is really multi-platform. It can run on any computer, any platform, any machine, any chip you can think about. And I've been in those projects. And it's amazing to write your code once, compile it anywhere, and then you get the same results. And it plays nice with other languages, because usually we don't live in a void. We want our C++ code base to be accessible from other languages such as Python or Java or C#, VB.NET if you do that. Or you want to call those libraries from our library and harness some library someone else has wrote. And it's highly extensible. We can create our own syntax in C++ essentially. We can do amazing stuff. We can define new types, and we can override operators, and we can play with macros, and do things that other languages can only dream about. It's also a good language for low-level programming. Who here does low-level programming? Okay, not as many as I expected, but yeah, good for you. We can call the GPU, or the CPU, or inspect processes running in the operating system, and that's because all of those were written using C and C++. The operating system and other compilers for other languages, and even languages that now have a managed compiler, such as C#, that managed compiler was written in C++. And the runtime they're running on, with this nifty garbage collection they have, was also written in C++, which means that as a C++ developer, I can somehow even know the way it was implemented. I can really understand those low-level internals, because I've written similar code. Now, all of you are C++ developer. Who here is a C++ developer? Raise your hand. Okay, most of the room, right? Okay. Who here only write C++ in one platform? Windows, for example. Okay. And the rest, do it for any other platform under the sun. Nice. Well, I gave this talk in NDC Oslo. There we had a lot of Windows developers, but different conference. So C++ is a powerful language, but with that great power comes great responsibility, because you really can mess things up with C++, right? You can cause amazing colossal problem with C++. Given to the right or wrong developer, C++ can cause crashes and faults and memory allocation issues. You just have to name it. So we need something in order to improve. And obviously, education is one of them. We need to really understand what our software does and how it does it, and know how we allocate or deallocate things, and how is the memory, the file system, or whatever is most relevant to your line of work. But I found there is one tool, and I'm highly biased, that helps me, and that is writing automated tests as well. Specifically unit testing, but not only unit testing, because once I start using unit testing, by the way, before I start, who writes unit tests for a C++ program? Excellent. This is most of the room. This usually doesn't happen. Usually I get a few people shyly raising their hands. So if you do write unit tests, then you're fine. Because writing unit tests means I can avoid those stupid bugs. When I was a young developer, just starting my way, I didn't know any better. I used to hack as quickly as I can, punch the keyboard, finishing that specific task, commit it, throw it over the fence to the next developer in line or a tester. He will try to run my software, and it will immediately crash. With unit test, that shouldn't happen. That doesn't happen, because all of those stupid bugs of dangling pointers or accidentally going overboard with your arrays need to be caught in this stage. All those stupid bugs disappear once you start to write tests for your code, and you get early feedback. Because the thing I hate the most when writing software is that 2 weeks after I finish writing something, I'll get a bug report. And if I get a bug report after 2 weeks, I have a problem, because I'm already working on something else. And I forgot what I did 2 weeks ago. And usually, the bug report, well, it depends on the tester you're working with, but some of them are not very detailed. Some of them, I got a bug report saying, software just crashed. Good luck. And then you try to reproduce that bug report. Obviously, it doesn't happen on your machine. And then you say, works on my machine. And you mark the bug as cannot be reproduced. And the testers get very annoyed with that and reopen the bug. And you start a small fight about it. It takes a few days, maybe a few weeks, until you actually get to fix that bug. I want to find my problems as quickly as I can. Once I write them, I want them to be found. Don't want to wait till a tester or a customer find them for me. And then the selling point for unit testing, most of the time people bring me in to explain and teach about unit tests when they find out they have a lot of regression bugs. They keep on breaking stuff, because this is a painful thing to do. You fix something and you break something, and you fix that and you break the first thing again. And once you have a lot of unit tests, you have a safety net that protects you from regression. And you can write sustainable and manageable code, because something funny happens when you start to write automated tests. Your code, your design changes. You start to write very loosely coupled design. You start to divide your dependencies from your core business, and your code changes to the better. I don't buy this whole design for testability thing. I design for readability and maintainability. I get to test it because of that, but that's it. My code becomes better. I have dependency injection, and I have different classes with single responsibility for each, and it brings me for a better object-oriented design intuitively, without thinking about it. And finally, unit tests are kind of documentation, at least for me, because I write code as fast as I read English. And that is a good thing. That means that when I get to the same project I worked on a month ago, or even before lunch, all I need to do is read the tests, run them, debug them, and understand how the code works. And unlike the text document that you might have written, your design document, it doesn't get stale, because the tests progress with your code, keep on changing and updated as your code updates. So unit test is a good thing to have. And it's a very simple thing, a unit test. Unfortunately, not only we have a lot of definition of what a unit test is, and you can argue about it till you turn blue in the face, I found that there is no clear definition of what is a unit test out there. You know, Google it, you find several definitions, some of them written by speakers that came here today. So I have my own definition. You know, if you can't beat them, join them. And my definition of unit test is very simple. It's a method. A unit test is essentially a method. All of us know how to write those. There are different tools, but it is essentially a method. And don't let anyone lie to you. There are no such thing as a unit testing framework. Those are method running frameworks, and that's it. They have nothing to do really with unit tests. They don't really check that you are writing a unit test. They just run code. But the thing that makes it a unit test is that unlike the code I write in production, it tests a very specific functionality. This is the thing I found developers find the hardest thing to think about. Because when we write production code, we usually need to tackle all of the possible options out there. And unit test is the complete opposite. I write a single unit test that tests something very specific. And it's hard to wrap your head around if you've been writing unit tests for some time, and usually in the beginning they fail because they are too complex and they have a lot of logic in them, and then you reduce that and you get to that specific functionality. Also, unit tests have a very clear pass or fail criteria, which seems trivial, but I've been in organizations in which they will run tests automatically, and then someone will get in the morning, some very poor developer or tester, and check the database or the server or the logs to decide whether or not the test has passed. And I don't want that. I want those tests to run automatically and just notify me when they fail. And finally, unit tests, unlike integration or acceptance tests that I can write using a unit testing framework, run in isolation. You don't get to call anything outside your code. You don't call servers, and you don't call any database, and probably not a lot of third-party libraries, but that's up to how you wrote your code and what you use. And the reason we're doing that is because we want those tests to run on any machine, including the build server, easily. I want the tests not to affect one another. I don't want the ordering of the way that I run the test to affect how the tests work. They should work in any order, in any way. I should be able to run the same test 1,000 times, get exactly the same result. Because if it fails, I want to run it at least one more time to see what happens. Now, all of this done by this simple guy, a method of unit tests. Anyone recognize that one? This is Google tests. Who here uses Google test? This is the most popular C++ unit testing framework out there. I'm not sure. The good reason is that it was the first, or at least the first maintained one. Well, one of the first. But all of them look roughly the same. And if you go to other languages, you can probably recognize the same structure. And the structure is combined from this. In C++, it's a macro, right? All the veteran C++ developers know that if I write it with uppercase, it's a macro. And that macro essentially does a few things for me. It creates a new class in the background, a new method in that class, and writes somewhere that this is a test and it should be ran when I run my tests. And in Google Tests, I will create an executable that runs all the tests with or without any parameters, basically. So this is the macro that makes everything happen. And here I have the name of the class in the background. We usually call those test fixtures. This is like a grouping of several tests that have something related to one another. Either they test the same component, the same part of the system, or the same functionality. But essentially, it's a class in object-oriented. And this is my actual test. Now, in Google Tests, it must be something that can be compiled as a method name, because it is the method name. And I try to use uppercase, lowercase, and underscore to make it barely human readable, so I will understand why the test failed and what it does. Here in the middle is the important part. This is where I do stuff. I usually do 3 things in every test. First of which is arrange. I'll arrange the system. I'll do something in the system to get to the point in which I can run whatever I'm trying to test. Here I only need to create a new object. And the second part is the act part. This is the play button. That's where I'll run the experiment, the test I want to check. And the final one is an assert, usually called assert, but it depends on the unit testing framework. And that assert will check something for me. In this case, check that I'll get false back from this method. And that's it. This is a very simplistic view of a unit test, but even more complex logic can be fit inside those rules. Now, in C++, and in any other language, to tell you the truth, a unit testing framework, so-called unit testing framework, will give me at least 3 things. First of which, I can declare test and test fixture, which are the containers of those tests and might have some behavior I need. I'll have a bunch of assertions. The number of assertions depending on the unit testing framework and its capabilities enable me to check for certain conditions. The more specified the assert, the better, because I'll get a better error message when it fails. And test runners. In C++, in most unit testing framework, and I'll actually create an executable, so I'll get to run that. But sometimes some unit testing framework are bundled with specific program to run them, and especially on Windows. And sometimes I get integrated runner. If you work in Windows, you can run some of those from Visual Studio, or you can run from Eclipse in Linux after doing some trickery, because most of the time I want to run them from within my development environment. Now, in C++ unit testing, there are good news and bad news. The good news is that you have a lot of choices. There are a lot of unit testing framework in C++. I've never seen so many in one language. And more than that, there are a lot of styles, because usually a unit testing framework, any language you choose, looks about the same way it was invented with JUnit back, I don't know, 2002 or 3? 1997, thank you. Yeah, on a plane to a conference. They invented that one, they wrote that one, Kent Beck and Eric Gamma. And they wrote JUnit with ideas that were right for 1997, a time that at least I wasn't in the software industry. And no one has changed that unless you go to C++, where people have thought about better ideas of testing your code. And I'll show you those. The bad thing is that you don't always get your documentation. Most of those are open source projects, people hacking away in the middle of the night. And so they don't really have a lot of time to write documentation. And well, most of the time you don't need it, but when you do need it, you wish you had it, when you need to do something which is not trivial. And amazingly enough, well, I'll talk about it, but the one with the least amount of documentation is the one that is maintained by the actual company. And not all unit testing frameworks are maintained, just like any other open source project. Some of them are maintained. I've just updated my demos because some of those frameworks were recent. The one was updated yesterday. People keep on working on them all the time. But some of them haven't been for years. And the ugly one is deployment. Because in C++, we don't have yet, well, we have some tries to have a better package management, Conan or VC package for Microsoft, but could be a pain to deploy those unit testing framework. And some of those options, you need to compile your unit testing framework itself, and you need to compile it the same way you compile your test and your code. You know, if it's debug or release, multi-threaded, single-threaded compartment, the same platform, and so on, which can be very frustrating, especially when you get it wrong. And then you get a bunch of very funny link messages, which is a terrible thing to solve, just because you compiled something not exactly the same way. Happened to me a day before a course. You don't want that. And in case of Windows, if you compile with a different Visual Studio, then it's no go. You'll have a bunch of linking problems, and you won't get away with that. And it can become painful. The good news about that is that many unit testing framework authors understood that, and they have better solutions. So we have quite a lot of unit testing framework, and I'm sure I'm missing some. I tried to get as complete list as I could, and I'll try to show at least a few of those. The first of which is obviously Google Test. In my experience, every single client I got to at least considered working with Google Test.
because it's widely used. It's sort of the go-to guy for unit testing in C++. They dominated the market for almost forever. And it's not that bad, Google test. And then I have Microsoft try at native unit testing. If you go into Visual Studio and create a new native C++ unit testing project, you get something called, I'll call it native MS test. I'm not sure what its name is. And it goes in a completely different direction, different API and different way to work than all the others. And then this is my favorite Catch, because Catch was written, by the way, by Phil Nash, who works for JetBrains right now. And it has a lot of very interesting ideas. I think it's one of the first unit testing framework that actually looked at JUnit and said, no, I don't want to do that. I want to do something completely different. And I think he got it right. From my experience, if someone starts with Catch, he'll miss a lot of the pitfalls that people fall in using Google Test. Not because it's a bad framework, it's just drives you in the right direction. And the CPP unit, it was created in 2000 by Michael Feathers, because he wrote a book called Working Effectively with Legacy Code, and he needed a unit testing framework for C++. So he wrote a unit testing framework for C++. And there's Boost Test. Anyone ever used Boost Test? Okay. Was it fun? It's very verbose. A lot of things you need to write. There, you could like it. It's up to you. You might actually like this micromanagement kind of style. That's okay. Not judging anyone. And there's DocTest. DocTest is interesting. It is one of the first unit testing framework that looked at Catch and says, I want that exactly, but a bit different. It has a similar syntax, but you get to write your test inside your production code. And actually, Phil Nash saw that and enabled Catch to do the same. So you get back and forth with ideas there. And the idea is that you write inside your production code, you write your test, and during compilation, depending on whatever preprocessor definition you use, the test could disappear completely when you want to give the code to your customer, or it can run if you want to run your test right now. And it enables you to test things that you can test from outside your library or executable. And there's less. This is another, I call them Catch derivative. It took the same ideas Catch has, changed them a bit. It's more manual, kind of sign your test, inline way. I'll show you that. And there's XUnit++. That one actually looked at a project in .NET called XUnit and said, I want that API, and created a similar API in C++. And there's Metal. Metal is completely different from all the others. It has a syntax you might like, and I found it to be very effective when you want to scare off Java developers. Let's see all those, shall we? Now, this project is on GitHub. Everything under Dror Helper, you can find that, and I'll give you the link at the end of the session. This is Google Test, as I showed you. I'm testing a bowling scoring game. There's a bowling kata. Anyone ever saw the bowling game kata? You might get it, yeah, in a job interview. And the idea is you get a bunch of results of playing the bowling game, and you check the score. And here in Google Test, I'll create a new game, roll several, got a ball, which means I have no score, and it should be 0. Okay? Now, this fine thing here is actually a resharper for C++ that enabled me to run the test from within the code, but I could have also run it from command line, or even these days, even using Visual Studio, I might be able, this is actually resharper, but I might be able to see the test here as well. Once it stops reading them, it will probably find a bunch of tests. And I'm sure we can create the same effect in Linux using your idea of choice. Now, when running this test, I will roll several balls and check the score. Now, the most important thing about any unit testing framework is the error message I will get when it fails. Because as far as I'm concerned, I'm only writing those tests to fail. If I had a way to know which tests will fail and which will not, I will delete all the tests that will never fail. But there's no way to predict the future, at least not yet. Because those tests are written to catch me when I write a bug, and that's it. And the rest of it is wasting CPU and my time.
So at least the least I can do is, if the test fails, I want the best error message I can think of. Now let's make it fail. If I'll do that, it's bound to fail. I'll run it using Dror Helper this time. And hope for the best, I guess. Here we go, it's running, and it failed. And I get a nice error message. And it doesn't matter which unit testing framework you choose. Run this experiment and see what happens. See whether or not you can understand the problem. And here it's very easy to understand because Google Test does an excellent job. It tells me what I expected to get, tells me what I checked, the actual method, and it tells me the actual result. This is excellent. And Google Test has a lot of those asserts. If I look at assert underscore, I'll get a very long list. It has assert death. The application actually crashed, which I didn't find any other unit testing framework can do that, or exit. And there's the usual suspect, false. Let's do that. Here we go. And yeah. And greater, and equal, and result, and near, and didn't for an exception, or use your own predicate. These days, with lambdas, we can define what we want the test to check. And so on and so on. And there are quite a lot of those, and string related, and so on. So this is actually pretty cool. Although I have another session about what I hate about unit testing framework. I hate choosing the right assert. I found developers usually in the beginning use assert true for everything, because that's the way we think, and it should be that way. And that's the first thing I actually like about catch, because if we go down here, or up there, here we go, and look at the same test with catch. Here we go. This is exactly the same test with catch. It looks related, about the same, right? But there's one big difference, and this is it. In catch, we don't have a lot of asserts. We have about 5 of those. And we usually use only one, and this is it, require, and write the actual code. Write what to expect the test to do, and that's it. And I like to write in code, and unfortunately, no other language enables me to do that nice. You know, in .NET and Java, you can have the same effect, because not only does I write it in code, but when I do get an error message, you know, using C++ trickery, and it's easier in managed languages to do the same thing. I actually did that for one client. And when I run the same test again with my catch test, you see the error message? You require game score to be equal 0, and 10, and 0 is not 10. You get a very good error message because catch knows most of the thing you try to write there. If I would have tried to compare strings, it will understand that, or something inside the collection, and so on. And this is a powerful capabilities because I don't need to think about what I'm testing, just write it in code, which I find easier. So that's the first thing I really like about catch. Now, we have other options here as well, first of which, as I said, a bit different, is Microsoft option. They saw what everybody else did and decided to go a different route. And that route very similar to what you'll see in Java and .NET. You define a test class and give it a name. And inside you have fields and public test methods, which is the actual test. You have this hierarchical kind of view. XUnit++ will do the same thing for you. Now, I found this library to be lacking. It doesn't have enough asserts for my benefits, and it doesn't almost no documentation whatsoever. But if you're a Windows-only shop, it will run out of the box. And unlike the other guys, it doesn't create an executable. You can only run it using Visual Studio from here, or Visual Studio Runner from the command line. Unlike the other languages where you just execute the code, which can be problematic if you're using other build systems, not Visual Studio ones. And I also found this hierarchy. I don't really like it that much, but that's my preference. And I promised at least one more, last. Here is last. It's very similar to catch, but you have to create a specification array, and then inside it you write all the tests here as test case, and then you need to explicitly run those specifications. Okay? Now, this was handled differently by different unit testing framework. For example, in Google Test, I just need to find where I wrote the main, probably here. There's a main because it's an executable. You need to write this magic, those two, in order to run the tests. And in catch, he said, well, no need to rewrite that code anytime I write a new unit testing framework. So there's a define that do that for me. Many languages do that as well. Another thing about catch, and I'm sorry, I do like it, is that all you need to do in order to use it is include a header file, which will also work for lest and doc test, many others, and you don't need to compile anything. And you can somehow get to Google Test to do the same thing. You can compile it to a single C++ file and add it to your project, but it's a pain. And just including a file, easier, although your compilation times might be longer due to that, because you're compiling it as well. And that's all I need to use catch. Include the header file, and define this define beforehand, and I'm ready to write tests, so deployment is easier. So this was a quick overview of all those. The others are derivative either of how Google Test does things, how Microsoft does things, or how Catch does things, with slight differences between them, API-wise usually. The other tool I usually need is a mocking framework. A mocking framework, who here was in my session yesterday? Okay, not enough, so I need to explain. A mocking framework essentially is when I need to isolate dependencies. I have a database or a server. I don't want to call those in my unit tests. So what I do, I take the class that calls the database, inherit it, and override all the methods, and I end up with a class that does absolutely nothing. And this is essentially a mocking framework. That's all it does. And you get a fake object that you can shove into your code somehow and replace the dependency you don't want to run. And you get to tell that mocking framework exactly what you want. I don't like calling that a mocking framework because it's very misleading and cause you not to use it, perhaps. A lot of developers think that mocks is very complex. You can actually write your own. Just inherit the class, override all the methods. But I don't want to because someone will do it for me. And I want to change the behavior in every test. And so I use a mocking framework that will enable me to create those fake objects. And set behavior, because in one test I want to throw an exception because the server is not there, the pseudo server, the fake server. And in another, I want to return some message. And that way I get to isolate the code I care about, the code I'm testing, from the outside environment. And the last thing a mocking framework will enable me to do is to check whether or not something was called. Now, also a good, bad, and ugly kind of situation. The good is that there are mocking framework for C++. There weren't to begin with. There are mocking framework right now, and we have quite a few now. We didn't have a lot. In the beginning, all we had is Google Mach. The bad thing is, yeah, everybody uses Google Mach. It's not a bad mocking framework. In the beginning, it was only the only one. Now, today, this year, or a couple of years, last years, we have a few more. And you need to beware because some of those are not maintained anymore. And the ugly one is that in most of them I still need to write quite a lot of code, which I don't like because code I write is code I need to maintain. Whenever my dependency has a new method or changes signature, I need to change my mocks accordingly. And most of them were written a while ago, especially Google Mach, and they don't really look like AAA. It's not arrange, act, assert, and they have a bunch of ideas that I don't really like. For example, you need to define all of the calls that will happen in your system. And then you write your test, and you write your mock, tell them, I expect method A and method B to be called, and someone changes the production code, add another method called. You don't care about that in your test. But Google Mach will be very angry with you about that. And you'll get warning or errors depending on how you initialize it. And I don't care about that specific call. Someone added a call to my code, didn't change the flow I'm actually testing. My test should continue to execute the same way. And unfortunately, that's not the way we thought things should happen in way back. And these days, modern mocking framework doesn't do that anymore. But in C++, some of them still do. And what do we have in C++? We have Google Mach, as I said, come bundled with Google Test, very good integration with one another. So usually when using Google Test, people tend to use Google Mach as well. There's Trampolet, written by Bjorn, who's, I think, speaking in the next room. And not Strustrup, the other one. And it's very similar to Google Mach, but a lot of modernizing done there. It's a single header deployment as well. And there are some ideas I think are good. In hindsight, some of them you think he made a mistake. I think he did the right choice there. And it's very interesting to use. There's Hippomach, which is still around, but I haven't seen it being updated for some time. And there's one innovative one called Fakeit. Fakeit, although doesn't mock everything just like Google Mach, it will only mock pure virtual functions, and you can't have multiple inheritance, but you don't need to write classes. It will automatically, in the background, do some magic to create your mock classes. And there's Isolator++. Disclaimer used to work for that company, which does something completely different. It uses runtime instrumentation to change your actual code during runtime to do absolutely nothing for you. Costs money, quite a bit. But you might want to use that because you don't want to refactor your code and you have a lot of legacy code, and it might be a good option. It used to be a Windows-only kind of solution, but they have Linux for the last year or so, and you might want to check it. I didn't get a lot of experience with it. I don't get any money out of it, so don't worry about that. And essentially, it takes all the pain away when it works, and you should check if it works for your project. It won't work on all platforms, and it does a lot of magic in the background dependent on your operating system of choice. Let's see those. Quickly, runner. So, going up here, let's start with Google Mach, always a good place to start. I showed the same one yesterday, actually. This is Google Test, and here I have a fake data access. Now, in Google Mach, you have to write your fake objects. You have to inherit the objects you want to override. This method, getData, is inside the data access, and I'll override it using Google Mach's macros that will essentially enable me to change the behavior of that method in the test. In the test, I can tell it what to do, but I do have to write the code to do that. This is the bare minimum I need to write. Essentially, it's a const method with no parameters called getData, and it returns a pair of 2 ints, and I know there's someone in the crowd that said not to use pairs, but that is a demo, so it's fine. And similarly, I have a fake REST API client, bad with name, sorry, and it inherits the REST API client. I'll do some trickery with the constructor not to call it, and so it won't connect to a server or anything. And here I have a method with one parameter called HTTP GET, returns a string, and get a string on the way. And the test, which I'm going to use for all my different examples, is my database returns this pair, and I do that with Google Mach by using expect call, and I expect that when I call getData, it will repeatedly, always, return this data. I can tell it to throw an exception or run custom code, up to me. There are quite a lot of options there. But this is what I need here. And I also expect my fake client to call HTTP GET with this specific string, and that's it, at least once, because in Google Mach, verifying and setting the behavior is done in the same place, which I don't like. I think they should be divided. But here I tell it not only you should return the number 3 as a string, but unless that call was made at least once, the test should fail. Okay, this is what I'm doing here. If you've never seen a mocking framework before, it's a bit complex. It takes a while to wrap your head around this, but essentially that's all you can do with the mocking framework. And then I'll create a new calculator and calculate the next data. And I found that running it in debug will probably help explain what happens there. So if I'll run, I'll get to the actual code I'm testing. You see, there's no assert here because I have no state to actually check because I faked out the database and the server. So what I need to check is that the server was called. If your test is that if the user is valid, send an email, you want to check that the email was sent, but there's no email, I just faked it out. So I want to check that the method called send in the email client was called. So no asserts. So the test looked a bit strange. And if I go in, this is the code I'm testing, very trivial. I would never test this code in real production systems. But here in get data access, I'll get data back. And the data is essentially exactly what I told him to, 1 and 2. That's what I said, but that's what happens. And here I'll build some sort of a string and run HTTP GET with that string. And now the test basically is over. I don't really care what happens after that because this is a fake object. I told him what to do just for the test to pass and not fail. But the actual result of the test is here inside the test, which is very powerful because I get to test things that are deep inside my code. I don't need some value. I'll just test something was called. And obviously, I needed to initialize the class with those fake objects beforehand. I did a constructor injection to do that, but that is part of using mocks. And this is how you do it with Google Mach. Now, with Trampolet, it's very similar. The actual test will look about the same with different values. Here is connecting. I told you that Google Mach and Google Test are tightly coupled. They're not tightly coupled. Well integrated is the word I'm looking for. So you don't need to do that. But any other mocking framework, you need to tell the unit testing framework we have a problem. And that's what I'm doing here. I copied that from the site. Don't worry, don't need to remember that. And this is essentially the same test, you see? Allow call, blah, 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 return, and require call for expectation. So we have 2 different APIs, but it is about the same. And if you look at fake it, in fake it, the nice thing is that I don't have any fake classes. It will do that for me as long as all the method calls are pure virtual. And in fake it, all I need to say is mock with data access, and I'll get a magic class already mocked. So I don't need to write classes, and if they change, I don't need to change all my tests. And when a method, HTTP GET, is called, return free. I find it to be more streamlined to read it this way, but I'm coming from other languages, and that's how we do it in .NET and Java. And I used to work for a mocking company, for a company that made mocking frameworks, and that's the API we liked. And the verify, checking that the method was called, is done in the end, just like an assert, which I like as well. It's more clear, understandable what I'm testing here, because it comes at the end. I'm checking that HTTP GET was called at least once. And if we go to isolator++, this is a completely different beast. First of all, you don't need to create any classes because it doesn't use any classes. It actually uses your real class. It just changes the way it works during runtime. So I have here an address, and I fake it. But not only did I fake it for whatever I have in this test, I fake all the future instances anywhere you write new with that class. This is immensely powerful. I don't need dependency injection because I told him that fake address, get city, will return London. If I'll take fake address and try to run it, fake address, get city, and run it, then, as you can tell, I'll get an empty string, right? But once I pass this line, like so, and do the same thing again, then magically, and this is a real class. I haven't created a fake object. It will return London. You see, I'm using an actual address, not just a pointer, the class. Now, what is really cool is when I call get address from city, factory, whatever, then it will use a singleton, return an address from that singleton. There's an actual new inside. We can run all the way there. It will new a singleton. And if we go like so, past that singleton essentially is faked as well, because I told him wherever you use an address, and its name is singleton now, singleton get city, and this is a class I just newed. It will return London as well. And this is amazing, and it might worth your money. Okay, I have no opinion on the topic, basically, depending on your project. And this is powerful capabilities that you can harness. Especially if your code is legacy code without any dependency injection, a lot of things stuck together, huge monolith, might save you some time, a lot of time. It might be worth it. And again, not affiliated with them, so that's it. Now in C++, we have something going for us. There's the multiple assert dilemma. Ever heard about the single assert rule? Every test should have only single assert. It is not a rule, never written anywhere. But it is true, because the more things I test in the test will be more complex. But sometimes my assert is actually a single assert written several times. For example, consider this example. I'm taking a string, and I parse that string, and I get a result back, a single result, but it has a lot of aspects. It's a movie. It has an IMDb ID, a title, a plot, and minimum length, okay? I want to test all of those. I don't need 4 tests to test that. Now, in other languages like C# and Java, I might have a problem because assertions there will throw an exception. That's how they work. Luckily for me, at least all of the unit testing framework I saw in C++ doesn't do that, which means that right now the test is a problem, because if I run the test, this time from the command line, you see it failed, and it failed because the movie name was not right. It was wrong. It wasn't what I expected. But I have no clue about the rest of the assertions, whether or not they failed or passed. And I like to get as much information as I can get. And for that, I can use something else, and all of those I just show you have the same capability, and that instead of assert, use some other word. Here they called expect. Expect says, if the assertion fails, continue till the end, and just in the end, tell me about it. And the reason we can do that is because those don't throw an exception, just like C# or Java. JUnit, that was written in 1997. And no one has ever thought about changing that ever since. But in C++ we have. So if I run the same test now that I change it to expect, insert assert, and I need to compile C++ for you, then you see I'll get a better error message. The movie name is not correct, and the plot is not correct as well. And this is better, because there's a difference between one property is not correct to all of the properties are not correct. And I don't want to write 4 tests, because essentially I'm testing just one thing. Another cool thing about unit testing framework in C++ is that it's more readable, in my belief, because failures don't throw exceptions, just like I show you. You get better failure message, usually in C++ than any other language, in my experience. I don't know why. And you have single powerful assert when going to catch and all its derivative, which also I find very useful. But there's another thing I like about catch, and that's section. Anyone here is familiar with test fixtures, setup and teardown? If we look at the same example from yesterday, in any unit testing framework, JUnit, NUnit, all of those, I have the ability to define special methods that will run before every test and after every test. I do that to enable code reuse or initialize my system and do things that so I don't need to do them in my test. So if I write it here and here, the setup and the teardown, then I don't need to write it in my test. And the tests look better. Unfortunately, I think it's a bad solution. And by the way, a lot of consultants will think the exact opposite. But I've seen people mess this up. Because first of all, a new developer will come, you want a different behavior, he'll write it here and mess up your test. Second of all, when this test here will fail, you start doing this. Go up, go down, go up, go down. Try to combine the test in your head. And in Catch, they did something completely different, although it does support the fixture if you want to. Catch, they have something called sections. And sections essentially is writing a mini test inside your test. You see, I have the initialization here, and I have the section that will run, and I have another section here, and they will run individually in different execution times. If one fails and the other passes, that's fine, I'll get those results. It's not like writing everything in the same test. And I haven't found a good way to do that in managed languages because C++ is more powerful, not in a good way, anyway. And those sections enable me to write better code. And when developers start with sections instead of fixtures, they usually write better tests as well, in my experience. So this is why I like unit testing framework in C++, and I think that you actually can do a better job with those. So how do you choose? There are so many things to choose from. First of all, decide whether or not you need multi-platform support. Some of those don't support your platform of choice. Most of them will. But for example, Microsoft unit testing framework only works on Windows. So you have to think about that. Second of which, is it maintained? Go into the GitHub page. See when was the last commit. Check whether or not it has documentation. Documentation is usually a good way to check whether or not a project is maintained or not. If it has an extensive documentation, says someone really cares about it. Ease of use. How easy is it for me to write tests? How easy is it to use the unit testing framework, deployment-wise and execution-wise? How can I choose to run just these tests? What happens when the test fails? See your test fail and see if the error message makes any sense for you. And the integration point in your environment development and your build system are very important. And also between your mocking framework and your unit testing framework as well. And finally, your personal taste. Because we are different. I like Catch, but doesn't matter because you might like something completely different. You might like metal, for example, because it makes everybody look at you differently. Because I haven't showed it because I didn't have a lot of time, but just a quick glance, you'll understand what I'm talking about. Google this metal. This is test with metal. Okay? Okay? Some people actually like this syntax. Some don't, and that's fine. If you like lambdas, you might like it better. It's up to you. And you might like XUnit++ because you come in from .NET or Java and it looks exactly the same. Again, your choice. Just make sure it's maintained. And finally, for those of you who have not written any unit tests, you have two options. In the middle of the night, trying to tackle a bug, and the way I see it, you have two options. Being frustrated, curse the language, be really annoyed with whoever wrote the code, or start writing unit tests. And it's essentially your choice. Always like to leave people with some quote I miswrote from a movie. So thank you very much. The examples are there under my user in GitHub. And you feel free to reach me, either Twitter or my blog. And if you have any question, I'll be here at least until the afternoon. You can come in, ask me, be happy to answer. Thank you for listening. It's been a while, and